It's all squared up.
Hello, can everybody hear me? Oh, I wonder if I should put my AirPods in. Can anybody hear me? Oh, technical difficulties. Has anybody made any comments whether they can hear me or not? So, Reese, what are we doing? So they can hear me. Okay. All right. All right. So my name is Richard Ross. Welcome to our presentation here of some of the things that we do here. So basically, what we do primarily at the moment is heat pumps. I guess most of the people here are kind of here for that. So we're going to go over kind of like low level basics of what some of this stuff is and how it works and what's required in order to get the job done. And then we'll go into some questions and stuff like that afterwards to answer any of your concerns or questions that you might have. So to start with mini splits, this is definitely our number one selling product here that you see up here on the wall. This is a Fujitsu 12,000 BTU mini split. So basically, you have your indoor unit, which is what's going to provide your heating and cooling. And then down here, you can see it. You have your outdoor unit, and that is basically the unit that is either collecting or distributing the heat outside or the cool outside, depending on whether you're heating or air conditioning. Excuse me. So basically, a heat pump is an air conditioner. The only difference between an air conditioner and a heat pump is a heat pump has a reversing valve. So they can basically do the opposite of one another. So when you are heating, the compressor outside is essentially a thief, and that's stealing the heat that's outside. And even though it can be cold outside, minus 15, 20 ambient, because we're always talking about ambient when we're talking about heat pumps, there is still actually heat in the air. Although we may feel cold, the machines don't. So effectively what this machine does is it will steal existing heat as it exists in the space outside, and through a compressor and then a gas refrigerant, it'll boil that refrigerant, turn it into a gas, run it up to an indoor head, and then that's basically distributing again the heat out into the room. So that kind of process starts from, so this is essentially what is in here, right? And that is your coil, and all your refrigerant runs through here. It looks kind of like a car radiator, and that will actually heat up, and then the air blows through that coil and into the room. And then in the summertime, it does the exact opposite. It will cool this coil because it's now stealing the heat from inside your house and then dumping it outside. So in the wintertime, if you put your hand in front of the fan, you will feel an even colder air out than what you're hearing here. What you have here. And then in the summertime, it will actually be blowing all the warm air out into the air. All right. So that's kind of like the basics for a heat pump. This is ideal for people that have electric baseboard, hot water baseboard, split entry. A lot of times, even if you have a ducted heat pump, these can sometimes work really good because they give you two zones. And then after that, you would have a ducted heat pump that would that there's a couple of options that we're kind of going to go through with those as well. The other one that we tend to be seeing a lot more of now are the Fujitsu floor mount models. So essentially, that is the same as this, but if you don't like the look of this and you are okay with the look of this, which is a little bit smaller, wider, taller, narrower. That is an option. They actually work really, really great. Sometimes, so when we're installing these heat pumps, basically what you're doing is you're typically on an outside wall. So we're going out with our line sets, which is our supply and return refrigerant lines, our communication wire, And then our drain line as well, because that water, when you're air conditioning, has got to go out and down in order to get a gravity feed. But this particular one has a sample of what's called a condensate pump. So if you do have to put it on an inside wall, it can be done, but we have to put one of these in, and essentially that is a pump that sits below the heat pump. And as you're air conditioning, that trap there will fill up. And once it hits a float, it'll actually pump the water back out. So that's for more like inside walls. If you have to go down into a basement, things like that. So that is an option. Yeah, so that's kind of like the general mini split kind of option for inside evaporators. And then the other thing that we do, which we actually do a lot of, and I'm just going to point my camera up here to see if we can get that. So this above us here essentially is an attic ducted unit. So this is a mini split, right? Same thing as this, but in a little bit of a different format. And essentially what that does is that goes and it conducts through the top floor of a 2-story house. If you have an open basement, again, if you really hate the look of these things, these are potential options that do work. So essentially down there, kind of at the left of your screen, you'll see what's called a return. It's hard for me to point with the camera. So this one right here with my finger, that's your return. So your return air basically sucks the air from inside the space. This is a closed unit. It sucks the air from inside the space. It goes through this air handler right here. Really hard to do. This air handler right here. And then from there, it branches out to your different leads. And then eventually out into your bedrooms, any kind of like closed, confined spaces that you have. And you can do multiple units. This one here has 4 leads off of it. You can do 6, 8, 10 leads, depending on the size of the house. So yeah, that's kind of like the rundown of all the basic mini split options that you have. Again, this is ideal for electric baseboards, hot water baseboards. If you heat with wood or anything like that as well, it's a good alternative. What? Yeah, well, we'll wait for questions till the end. All right. So, and then we're going to kind of move on to electrical and generators. So, heat pumps obviously use electricity. There are commonly 3 different types of electrical services in a house. The service in your house is defined by the main breaker that comes into your panel here. This is typically at the top. Sometimes you'll see them at the bottom. Every once in a while, you'll see them in here. And then on that is indicated the actual amperage of the system. Now, I know sometimes people think, well, you know, this has 200 and this has 200, therefore it's a 400 amp service. That is not the case. This being 200 and this being 200 means that it is a 200 amp service. Now, this is typically in your electrically heated homes because electric heat takes a lot of power. When you go to oil houses, a lot of times you'll have 100, 100, sometimes you'll see 125, 125. This does not necessarily mean if you have 100 amps, you can't do a heat pump. You can still do a heat pump. Often you can do 2 or even 3. But the caveat is if you're going to keep oil as your backup heat, because you'll always have to have a primary heat source with a heat pump of any kind. So that's either the primary heat sources are going to be, they're going to be oil, they're going to be electric, they're going to be propane, they're going to be natural gas. One of those, propane fireplaces, wood stoves, pellet stoves, they're in the same ballpark as a heat pump, as technically a secondary heat source. Now the heat pumps, they can do like 100% of the heat almost, I mean the new technology now, almost 100% of the time, if not 100% of the time. But insurance and for your own safety, we recommend that you or require you to have a primary heat source, which is one of those electric, oil hot water baseboard, electric boiler, hot water baseboard, oil forced air, propane furnace, propane hot water, any of those. So yeah, so this is a 200 amp panel. You have a smaller panel. Another thing that we get asked a lot about is a generator panel. And that kind of ties into the GeneraLink. They're kind of like two different solutions. This solution here is something that you can do where you can actually take like your own portable gas generator that you fire up with a cord or have even a press button, and then that would feed this panel. You are required to have this panel if you were to run a generator, and the reason being is that this generator panel will actually isolate itself from the main panel. And the reason being is if you were to hook your generator into the main panel, fire up your generator, not only are you feeding your house, you're also back feeding the grid. So that what ends up happening is you're juicing the lines. And what you can do is, you could kill somebody if they were working on the lines outside in front of your house. And I know that Nova Scotia Power really frowns upon this kind of behavior, but anyways, if you do it, you'll find out, maybe. So yeah, so that's a generator panel. That's kind of like the smaller, you buy it at Costco. It has gas. You store it away in a garage or something like that. Then the other alternative is kind of like the big one, which is the Generac. You can't even see it there. The Generac generator. So the Generac generator, this is a propane standby generator. This can run an entire house. So basically, what you have is an automatic transfer switch here. Similar kind of thing as what this is. Isolates the generator from the panel, but it knows when the power goes out. And when the power goes out, it sends a signal to the generator. Generator fires up, powers the panel, isolates from the grid. And then that runs your entire house on propane. It's a beast, serious machine. These end up being anywhere from $12,000 to $15,000 typically, but it is nice and quiet too. All right, next on our list, I guess. So we'll come back over here and we'll go back to solar. All right, so solar is actually quite popular now in Nova Scotia. We actually have the best program for solar power in all of Canada. Currently, Efficiency Nova Scotia is rebating up to 60 cents a kilowatt, up to 10 kilowatts. So you could effectively, on a 10 kilowatt solar installation, have a $6,000 rebate on your purchase, which is huge compared to anybody else. So basically, the basics of solar, kind of low level again. Your solar panel creates the energy. We actually can come up with a simulation of what it would be like if you had solar on your house. All we need is a copy of your power bill, and we can actually plug it into a software that we have, and it'll come out with a plan that'll tell you, if you put these panels on and you use this inverter and, the sun goes in the typical trajectories that it does in Nova Scotia every year, it will accumulate this much in power per year based over 30 years. And it can even give you the payback. The paybacks are actually really good on these. I see 8, 9, 10% returns on these quite often through our simulator software. There's actually a guy from the federal government that actually does up all of our plans for us. And then your solar panel, it feeds through an inverter. So when this creates electricity, it creates electricity in DC. So DC electricity. What you actually run in your house is AC, alternating current, right? So this is not the type of electricity that goes straight into your house. So you have to have some sort of an inverter. So what happens is the DC comes out. It can either be done through a couple of different methods. You can have what they call micro inverters, which is an inverter that goes on the back of the panel. It immediately inverts the power and then goes back down onto the grid. The one that we go for now is what's called a DC optimizer. So effectively, the DC is made off of the panel. It's optimized through an individual optimizer on every single panel, and then it's sent down to the inverter, which has DC. It flips it to AC. So hopefully someday when batteries kind of come along the line and they kind of progress a little bit more and become a little bit more affordable, and we're going to use them more in electric cars and stuff like that, this can essentially, before it changes to AC, throw it into a battery, right, in DC. So otherwise what happens is you're inverting it into AC, and then you're converting it back into DC to go into a battery, and then you're converting it back into AC to go back into your house. So this goes from DC to DC to DC. You get a lot less loss through that versus converting back and forth and back and forth. So we're hoping that, down the road, electric car car charger, the juice box, is really, really quite cool. Next, we'll go to ETS units. So ETS units, we may have seen them before in other people's houses. This is an ETS unit right here. So essentially, this is a bank of bricks that are inside that box. In order to get on Nova Scotia Power's time of day meter, which you may have heard of, or you already think that you're on, but you're not, you have to have one of these installed in order to get on the time of day meter. Now, the time of day meter is Monday to Friday from 11 p.m. until 7 a.m. Friday from 11 p.m. until Monday morning at 7 a.m. All your national and provincial holidays, they charge you half price electricity for the whole house. So this not only effectively charges itself at half price, which makes it effectively 2-to-1 in savings. What it will do is it will also attack the other things in your house. So we do often pair that time of day meter up with a heat pump. All right. So often what will happen is we'll put the ETS in the basement, and then that's what we need to get you on the time of day meter. Sometimes you need two. And then on the main floor, and then anything above the main floor, we typically look at heat pumps. The big reason for this is that the time of day meter being at 0.5 in the off-peak hours really benefits the heat pump. So heat pumps, they typically run at anywhere between 300% and 600% efficiency, right? So for every 1 unit that you're going to put into a heat pump, you're going to get 3 to 6 out of, all depending on the time of year. So if that's running on the time of day meter at night, all weekend long, you're actually running 300% on half price electricity, which is giving you 600% or 700% or 800% effectiveness because it's running on such a cheap rate. Those are typically actually our cheapest combo with the highest return, combining the 1 heat pump and 1 or 2 ETSs, depending on the size again. So I'm just going to have a quick sip of water here. Next, we're going to go on to ducted heat pumps. Oh, I think I did something here. Ducted heat pumps. So I made it come back a little bit. So this is a ducted heat pump. All right. Now they come in ones that look like this as well. All right. So they come in the ones that look like that. They're a little bit more expensive. They're the new inverter style of heat pumps where they have short double stack, not the big boxy. These are all like single stage, 2 stage or 3 stage compressors. We generally sell single stage. So York is the one that we typically sell. So essentially, this is like your furnace replacement. So if you have an oil furnace and you're looking to come off of oil and get rid of it forever, which we do a ton of, this is the kind of solution that you would typically look for if you have the ductwork already in place and have like 2 stories. You can do it in a split entry as well, but definitely for a 2-story house because it goes through all the ductwork through the whole house. All of these we always have to have a site visit for sure. So yeah, that is your outdoor compressor, which does the same thing as a mini split. Your compressor collects the heat, runs it into the furnace here, where it will heat and cool your house. And inside this particular one is an electric backup. What we can also do is we can do it while you stay on oil, right, which doesn't require a service upgrade for most. Is we could do an outdoor ducted unit, and then what they call an add-on. So an add-on is where you would be keeping your oil, and essentially if your furnace was kind of like this, right, what we would do is we would cut the furnace plenum open, and then we can slide one of those coils into the furnace and we seal it all back up. And then we basically put a thermostat in that communicates with the oil furnace and the heat pump, and then they know how to work together in order to make sure you're warm all the time, right? These are really cool. They're a great solution, but their limitation for me typically is that you're limited to one zone. So you'll have a thermostat on the main floor, and that drives the entire house from that one space. That can suck because, you know, anybody who has it knows that or experiences that if you have the thermostat on the main floor, often what you'll do is you'll end up having a cold basement because the sun comes in and collects the heat during the day, hits the thermostat, tells the thermostat not to come on when the basement still needs heat, and it can't differentiate between the two. So there are some limitations to that as well. And then kind of finally with what kind of like our kind of overview here is hot water tanks. So we typically do two types of hot water tanks. This is our heat pump hot water tank. So it is a heat pump, right? It is a heat pump with an electric backup. And essentially, the heat pump is running and heating the hot water. It wraps the same kind of coil thing around the tank so that it actually heats really, really well. We could duct this off to vent outside if you wanted to. It takes its air from here. It has a filter. You can control this thing through Wi-Fi. You can control your phone. And then the other one that we do a lot of is the Marathon tank. And this is kind of like, this is like the bulletproof hot water tank. It comes with a lifetime warranty. It's a polyurethane with a titanium coating. It has R20 insulation. I mean, it's like the insulation in this tank like this. I have one of these in my house, and our power was out for 6 days. We said, okay, no showers for those 6 days. And on the 6th day, we can still wash our dishes with warm water. It's pretty crazy. So they once they grab onto that heat, they hold on to it. So that's kind of like the rundown. I think the guys here have some questions that I'll read off myself, and then I'll. Okay, so I've got one here. If you want a unit upstairs where there are just bedrooms, would a heat pump be mounted on an inside hallway? Generally, I say that no. I mean, we always have to see the space before we can actually really give you the right advice. But those, in my opinion, they suck in bedrooms and they suck in hallways. So they really want to be in kind of like the more open of spaces. They don't like doorways. So, you know, you can strategically place them sometimes, but when you put one of these in a bedroom or in like a small hallway, what happens is you're actually oversizing the heat pump for the space that it's in. So essentially what happens is if this comes on, it blows out all the heat, and that heat traps, or the cool, traps in that immediate area, and then the machine just shuts off because it thinks it's already done what it's supposed to do. It's called short cycling, so they just shut off and off and off and off. In a bedroom, that can be annoying because it is coming on, comes on for 3 or 4 minutes, and then shuts down. And you can actually hear that going on. When you're doing the bedrooms on a 2-story house, I always recommend one of these. It is the attic ducted system. It is more expensive, yes, but if you want to hit 3, 4, 5, 6 bedrooms on the top floor of a house, in my opinion, this is the only way. And the reasons being is that this is actually in the attic of your house. So the machine itself is separated well from you and where you sleep. So the noise level, our customers say, like, you can't even hear it, right? You can't even hear it running. It just makes it great. It makes it cool, makes it warm, it makes it comfortable. Each of these, and everyone, and then another question, a lot of questions I get is, can you get separate thermostats for this? No, you can't. But if you can see the vent right up here that I'm pointing at, essentially, there is a damper, and it's called a butterfly damper. I'm gonna hold this up a little bit closer so maybe you can see it a bit better. All right, so that's the damper on there. It's a butterfly damper. When you twist the wheel that sticks down from the bottom, then it will actually close or open the vents. So if you want less air in this room, you can kind of close the vent. And what that does is that puts back pressure on all of the other rooms, and you can balance the system from left to right, side to side. It's actually really, really good. We get such great feedback on them. It's a game changer when it comes to the bedrooms. It adds about $3,000 to the price of adding one heat pump, but you can get 3 or 4 or 5 bedrooms from around the same. You know what I mean? It's otherwise you're spending $12 or $13 or $15,000 to put one in every bedroom, and it's a waste of money as far as I'm concerned. Yeah, so that's one. Let's go on to the next one. How much space do you need to install on an external wall? So, I mean, it's not a whole lot of space on an external wall. You got a couple of different options. This is 37 inches wide for the Fujitsu. This is our #1 seller. Comes with a 12-year parts, 10-year labor warranty. It's another thing. When you're looking at a heat pump, man, can you make a mistake? All right, just like anything in life, if you don't buy the right heat pump, or for that matter, choose the right contractor, you can have such a bad experience. Not only can you buy a piece of junk for the same kind of money as you would buy for one that's amazing, right? But they're hitting home runs and they don't care about you because they're selling you pieces of garbage. And this one here, Mitsubishi, Daikin, Fujitsu. I mean, mine is Fujitsu. I'm a Fujitsu man. But Mitsubishi, Daikin, they're the top 3 heat pumps out there. They have the best warranties. Generally, the installers are relatively hand-picked. So you can trust that you're actually getting the right people to do the job, because this isn't a weekend warrior job. You don't pay Bobby down the street to come in because he thinks he knows how to put in a heat pump. Don't waste your money. Don't. Not only are you not going to have warranty, they're not going to know how to fix it. Right? These things are like brain surgeons. They are not a furnace where you only have 5 parts that you need to repair. There are 350 parts probably in each of these machines. Right? It's just, yeah, you don't want to be messing around with that. How efficient are the heat pumps in a mini home? So mini homes, awesome, because they're almost always electric, right? And you generally have enough power. A mini home can have its limitations though. Mini homes are a little bit narrower than houses. And then what happens is if I put this on the wall here, and then you've got kind of a 16-foot wall on the other side, we're kind of pointing across when you've probably got 20 or 30 more feet to the left and the right. So when you actually have that up on the wall, your expectation is going to be kind of like the immediate space you're going to get, which is the bulk of the space and where you always want it the warmest anyways. But then depending on the layout of the mini home, when you get to the ends, you can start losing some of that. So there are sometimes strategic places we can put where we can get like 80-85% of a mini home. But really, if you put one of these and you already have electric baseboards in there, it's just a no-brainer, right? Like this will save lots of mini homes $800 to $1,000 a year for a machine that costs you $4,000. It's a 4-year payback, right? It's definitely the way to go. And then the air conditioning, and some people, I get customers a lot that say, oh, well, I only turn the air conditioning on for like 2 days a year. Why? It costs you pennies a day. It costs you like 30 to 50 cents a day on the hottest days to run one of these. So you just get yourself comfortable. And the same thing with the heat, right? You know, like, yes, you want to be conservative, but you also want to be comfortable. You don't want to come home and say, oh, okay, we'll go home, take the coat off, put the blankets on, put the slippers on, and then go on with that. With the heat pump, just be comfortable, right? It really doesn't, it doesn't grow the way it does with like the fossil. I mean, the fossil fuels are cheap right now, so nothing beats that. That's another thing I get a lot is, what does it cost to run one of these compared to oil, right? Me personally, been doing this a long time, probably been in 30,000 houses over the last few years. I kind of compare it to about a 70-cent liter of oil. So if home heating oil is 70 cents a liter, you're going to break even with the heat pump. If oil is $1 a liter, you're going to save somewhere around 30 cents a dollar by using the heat pump, right? If the oil goes up to $1.30, you're saving 60 cents. But right now, I mean, it's at 50. So this in the wintertime would actually lose you 20 cents on the dollar because oil is so cheap, but it's not going to stay cheap that long. And we all know that's going to go up. So required maintenance for heat pumps. So there's really not, like, there is required maintenance for heat pumps in the sense that you want us to come out and kind of clean the machine. So where's my coil here again? So in your indoor unit, you have your coil, right? There's tons of air, like millions and millions of cubic feet of air blow over these coils over the course of the summer and the winter, all right? Over the course of the winter, it's just dry air blowing through. Over the course of the summer, this coil is actually condensing the moisture that's in your house because this coil is cool. And when warm air blows through a cool coil, then what you do is you get condensation on the coil. And because there's so much surface space, I mean, if you were to flatten this thing out, I mean, it would fill the entire floor of this room. I mean, there's thousands of coils, right? Essentially that's picking up, and in the summertime on a really hot, humid day, this thing is going to be picking up. And if you go out to the drain line down outside, I mean, you could fill a pint glass like every 35, 40 minutes potentially with this on a real nasty day. It's really crazy how much water these things can remove. But as we all know, you have a coil that might be wet or will be wet in a machine that is dark with dirt that can pass through the filters. So they do over time have to be cleaned. They will get a buildup on the coil. There is a fan wheel in here that will get buildup on it as well. So we say every year or two if you really keep your filters clean, right? So those are your filters right up there. They come out like this, right? Easy. You can probably see the dust right there coming to this one. But anyways, just rinse them off in the sink. You don't get these interior filters wet because you'll have to replace them essentially, right? Then you just slide them back in. It takes 2 seconds. 2 seconds, right? So you keep those filters clean. You know, every house is different. We always say after the heat pump's installed, you check at 30, you check at 60, you check at 90 days, right? One of those days is going to be your interval. If it doesn't look dirty in 90 days, do it anyways, right? And then your fan that's in behind here with your louvers. So once every year or two, we will come out and we actually take the casing off the head and we put a bib up underneath, right? There's a bib that comes up right underneath. And we actually power wash the inside of the machine, the fan, and everything. And if you have had a heat pump for like 5 or 6 years and never had it cleaned and you use it for air conditioning, you will be disgusted with what comes out of that thing, right? It is like a black putrid. So yes, you definitely want to get those cleaned every once in a while. It's $149 for the first head. And then $79 for any additional head that we would have to clean. All right, for a smaller bungalow, single story, what would you consider the best heating cooling solution after taking out oil and a wood furnace? So if it's a 2-floor bungalow, taking out the oil furnace, I mean, it really we have to kind of see it to give you the choice and selection. But you could potentially single story. It's a single story. So single story is probably going to be mini splits. Excuse me, I gotta take a sip of water. So a single story, if it's open plan, I mean, geez, you can hit one, the whole place from one of these, right? Depending on the layout. You might have to add two if it's all choppy and whatnot. But this cannot be your only source of heat if you have oil currently or wood. We have to change that primary heat out to electric, oil, hot water, baseboard, electric, any of those things. You have to have that primary heat. This cannot be your only source of heat. One, it has limitations, technical limitations, but really not really limitations. These things will heat all the time, but they will break down. This machine will break down. That machine will break down. If that breaks down on the coldest week of the year, I have 200 other people who also have their machine down, right? So if their machine's down and your machine's down and there's 200 of them, I'm not coming to see you today, right? We will get there as quickly as we can, but even if we come out and find out what the problem is, we still have to order the part. Again, this is not like the furnace. The furnace breaks down, guy comes out, there's one of 6 parts, he goes out, he gets his parts, he comes back in, fixes it up and away you go. He can fix basically any furnace out there, right? Heat pump's different. You have a different coil, a different board, a different line set, a different machine, a different brand, all different things. So we don't carry all of these parts on our trucks at all times. You have to carry a tractor trailer around with you just to carry the most basic parts. So we have to come out, we have to diagnose, then we go back and we have to order the part. Then we have to arrange to get the part picked up. Then we have to arrange to come out and see you. You might be down for a week, and this could be in air conditioning as well. It is an unavoidable possibility, right? These are extremely reliable. They break down hardly ever. The only reason that we get sometimes so many service calls is we literally got thousands and thousands and thousands of machines out there, right? We're probably somewhere around 8,000 to 10,000 machines out there right now. So yes, we do get crazy at times, all right? High ceilings will do heat pumps. Yeah, I mean, yeah, anything with high ceilings, you can definitely do a heat pump. We are currently doing home visits and assessments. When we do come out, we do wear masks. Even when we're doing our installs and stuff like that, we take it very seriously. The only thing that we haven't been doing is we have not been wearing gloves, because I personally believe that it's questionable whether that is effective or not. But certainly the mask, we want to wear that mask for your protection. We hope that you respect us for our protection as well. Yeah, so do ETS inducted heat pumps work together? This is a question that I have heard 100,000 times. And to this day, I can't give you a 100% answer. They, in theory, should work well with ETS, especially, right? And this is where I kind of lean more towards, yes, they do, is usually if you have a ducted heat pump, your basement's cold and it sucks, right? And you're trying to find ways to heat that basement. And ETS, I think, is a great option for it. However, right, it's going to really depend on the heat pump that you have. If you have a heat pump that doesn't run efficiently, it can actually hurt, because during December 1st until February 28th, there are 2 peak periods during the day where they charge you a little bit more for electricity. So if you're not efficient, you are going to be burning through electricity. If you are efficient, that peak doesn't matter, right? The peak doesn't matter at all, because it's hardly even affected by it, right? But if you have something that's just burning through everything, like you wouldn't do ETS in one room and then run electric baseboards throughout the house. It just doesn't work that way. You have to store or you have to reduce in order to benefit from time of day meter. How easy is it to mix the attic in a 2-level home? bedrooms on the second floor. Yeah, so essentially what we would typically do is on a house where you've got like a 2-story house, you've got 4 bedrooms above, or 5 or 3. What we would do is we would do this on the main floor. Some people will do that in the basement as well. It's up to you. You can do what they call a multi-zone. So you'll have your outdoor compressor, right? That will run up to like 1, 2, 3, 4 heads. That's called a multi-zone. So 1 compressor, multiple heads. All right. I am of the firm belief that, especially for the main floor of any house, doesn't matter what house it is, the main floor should always be a single zone heat pump. All right. So the single zone heat pump is going to be it's going to be 30% more efficient than any multi-zone out there, right? These are, especially the Fujitsu, they are killer on efficiency, and especially in the single zone. So I always think of the main floor of the house as the meat and potatoes. So by the meat and potatoes, I mean, you've got your main floor, you're going to blow out that heat, and where does that heat want to go, especially if you have 2 stories in your house? It wants to go up. So it's going to climb up through the house. So if you can get that one to be the most effective heat pump, that's where you're going to get your biggest benefit from having a heat pump. And then upstairs, the attic ducted system, because that way we can get to multiple bedrooms from one single system that's going to run. Like when this is in your living room or wherever it is, and you're doing stuff, watching TV, talking, you don't even notice it, right? But if this is in your bedroom, right, and it's too big for the bedroom that it's in 100% of the time, right, it's going to be coming on and off and on and off and on and off. That can be annoying. And as the machine ages, it will become a little bit noisier and noisier and noisier over time. So for that reason, if there's any way to afford the attic ducted, or even save for a little bit longer in order to do so, I highly recommend it when you're trying to get multiple rooms in a choppy place. It's just the right way to do it. Yeah. Let's see what else we got here. Can heat pumps work with smart thermostats? So a heat pump, depending on what you're doing, they can. Fujitsu do have a smart capability. They have their own proprietary app that you can control the heat pumps from. LG as well. There's a few other brands out there as well. You download the app, you can turn it up and down and all that kind of stuff. I've always found them to be a little bit finicky. Some people think that they're friggin' awesome, and then other people are like, well, it didn't really work for me. It's there. But sometimes if you're way too far from the Wi-Fi bridge, I mean, there's all kinds of factors that are involved there. But it's really cool. The other thing that I say to people, though, is with a heat pump, it's different because it's so efficient. You don't go and turn it on and turn it off, or turn it up and turn it down, only according to your comfort that you want. You don't go to bed at night and lower it to 16 degrees. A heat pump is different. Your oil furnace, your electric baseboards, your hot water baseboards, they get really hot when they're trying to heat the space. So they radiate all of this heat, and they can do it in a pretty rapid time, right? Like you can have in a forced air furnace, I mean, you come home on a cold day, that could be up 6-10 degrees in 15-20 minutes. If you were to do that on a really cold day with a heat pump, you will be waiting for a very long time. So this can only accumulate so much heat at a time. So basically, if you turn it down 5 degrees or 6 degrees and you come home on the coldest day of the year, your house might not get warm until morning, unless you're going to use some sort of a backup heat, which is not desired. So split entry generally are number one results, because you can literally generally hit the whole house from 2 heat pumps. And from 2 heat pumps, I mean 2 heat pumps. 1 heat pump, 1 compressor, 2nd heat pump, 2nd compressor. 2 single zone heat pumps. And, split entries, bungalows, 100% of the time, I mean, even 2-story houses, main floor, always single zone, because that is the one that gets you all the benefit, right? Downstairs, you're below grade, so the ground's up to, sometimes it can be, 4 or 5 feet, and the ground is the best insulation on the planet. So you're really not having, and your windows are this big, right? So you're not really having a huge amount of heat loss out of your basement. Although people do say, "Oh, my basement's cold," it's because you don't have enough heat down there. So that is the second most important place if you're going to be doing a single zone. But if you're hitting the whole floor, the whole house with 2 heat pumps, 2 single zones, right? They last longer, they work better, they're more efficient, they break down less. If one dies, the other one can still live another 5 or 10 years. You never know. And you're not replacing the whole system all at once. It's just definitely the way to go. The difference of cost is about $700 to $800 when you're factoring in rebates on Fujitsu. And a 12,000 BTU Fujitsu that we sell, which is our #1 seller, does up to about 1,000 square feet. Maybe a little bit more if it's a nicely insulated house. You're looking at $42.95 plus tax. That comes with a 12-year parts, 10-year labor warranty, right? So that's another thing that you want to think about when you're buying a heat pump is what is the warranty, right? Because this is an unknown for you and the province and stuff like that. At least if you've got a good warranty, you know you're not going to have a bad experience. So the way this warranty works is that the first year you pay nothing. Doesn't matter what happens, doesn't matter what goes on. We stand behind our machines 100%. Years 2 to 10, if I have to come out for repair, there is a $150 deductible, but that's all you pay. So the worst case scenario is year 8, your compressor goes. And that would be, could be a $1,600, $1,800 repair. It costs you $149. So it is real peace of mind. We will stand behind it. We will not let you down on these things. And Fujitsu won't let you down either. I mean, I've been seeing it for 8 years now. Never seen a really failure yet. You look on our Facebook page, look on our rarely do we have a customer is let down by us, right? Do attic units? Yeah. So okay, that's a really good question. Do attic units require filter cleaning? And should ducts be okay? We'll go about that one afterwards. So these attic ducted units, all right, they do have a filter box. It's right there, right? And unfortunately, I'm in the office right now, so the ceilings are just too friggin' high, right? But if you can see, let's see here. It's hard for me to tell what side I'm on. If you can see where my finger is right there, you can see there's a little kind of like a little thumb tab there, right? You push that one in, you push that one in. This whole screen pops down. And if you see up there, you can see that the filter's actually in there, right? So you just slide that 20 by 22 filter out and you replace it with another one. You do that every quarter. It takes you 2 seconds to do it, but definitely worth doing. I mean, even ours, it's a little bit embarrassing. These things are white when they go in. And I don't know if you can see it well, but this one's gray, right? So it's full of crap. We have not done our due diligence on that heat pump. So ducted inverter system, is there a max distance between air handler and the compressor? Generally, not really. Residentially, I mean, commercially, yes, these things can go a pretty long way from each other. The only thing that I will say is that once we get over a certain amount of length, one thing that I think some people don't necessarily realize is, yes, you have to buy the heat pump. And yes, you can see on So Good to Buy or something like that, you can buy a heat pump for $895 plus tax, right? But that's the heat pump. You still have to buy the bracket, the stand, the slim duct, the line sets, the communication wire. All of these things add up to almost, if not more than the price of the actual heat pump. So I can buy a heat pump, yes, and I can buy it for $895, right? It's a piece of garbage. This cost me $2,500, right? So although I do sell it for $42.95, I still got to get an electrician out. I still got to get a red seal refrigeration guy out. We have to buy the line sets, the stands, the slim duct. I mean, I'm not hitting home runs, right? I hit lots of singles. We want to give you value. We want to give you quality. We want to give you service. But we still do have to make money. So we are not ripping people off. If you pay, $4,000 for any machine that is not either a Mitsubishi, a Fujitsu, or a Daikin, you are overpaying, right? You are overpaying for a worthless piece of garbage almost every single time. All right. So those are the points there. How well do heat pumps work in a 2-level garage? Do them all the time. The only thing that I say about a garage and a heat pump is that if you're heating a garage with a heat pump and it's the wintertime, if you open the door on a really cold day, it's going to take you hours to build that heat back up in that garage because you have just let it all out, right? Some people have like the wood stoves or the oil furnaces that just vent right into the room. Well, I mean, again, you open the garage, shut the garage, it takes 5 minutes, 10 minutes to warm up the room. You do that with a heat pump on a cold day, hours, right? And on a 2-level, depending, I mean, we're not really looking at as much at efficiency in a garage sometimes. Maybe you would do that on a dual zone and have kind of one compressor, 2 heads. But again, everything, we don't operate in New Brunswick. Nope. What manufacturer has the easiest parts to get? That is a question I used to get all the time because there was a couple of companies around here saying, oh yeah, don't buy Fujitsus because their parts are hard to get. That is bull. If you're looking at Fujitsu, Mitsubishi, Lennox, Daikin, LG, all of these are brought in by good companies. They're brought in by good companies that provide good service. A couple of those might not be the greatest of machines, but any of those machines you're going to have great service with. If you don't recognize the name of the machine that you're buying, if it's a Tossit, if it's like a bunch of these other ones, right? Don't buy it, right? Everybody's heard of, most people have heard of Fujitsu. They do all kinds of things, right? They're not just a one-trick pony. LG, everybody's heard of. Mitsubishi, again, they make cars, they make all kinds of things. These are all great machines. Also Japanese and Korean, by the way. So they do make really, really good machines, robust. But I mean, again, like we do sell LG as well. That's kind of like our entry-level brand. But you can see like when you actually come up as far as like the build, right? So you've got the Fujitsu here. I mean, this head unit is actually quite a bit bigger than this LG unit, right? And there's a price difference because of this. Because again, once you get into your actual machine here, you've got, this is all steel, aluminum, and copper. All right, it's not plastic, right? It costs money to make these machines, and the more steel, aluminum, and copper you have in a machine, the more expensive it's going to be, right? Because they're rarer metals, right? The steel is steel, but aluminum and copper. Is the ROI 4 years? So depending on what you heat with now, how you heated before, how you heat it with after. I mean, I manage our Facebook page. I get all kinds of people all the time going, oh, well, my heat pump didn't save me any money. And then you actually I start questioning them. I'm like, okay, well, what kind of heat pump did you buy? Most of the times when they've not saved any money, it's because they bought a bad heat pump from a bad contractor. I want to say a 4-letter word, but I won't. You can have a bad experience with the heat pump that you buy, or you can change your habits. That is the one that I see all the time. So I'll go into a house and I'll say, hey, you're keeping it pretty cold in here, right? You see all kinds of blankets out there, and you got your toque on, and you got your coat and you got your slippers, right? And then we come in and we put a heat pump in, right? And they go, my power bill went up. And I'll go, okay, well, let me come out and see you. And I walk in and it's like, whoa, it's like 30 degrees in here. What are you doing, right? Well, if you're heating at 15 before and you buy a heat pump and now you heat at 22, yeah, you're not going to save that $1,000 that you were thinking, right? You're going to save like $400 or $500 because you've changed your habits, right? You can't change your habits and expect the same result is if you didn't change your habits. All right, so it all depends. Electric baseboard, 100% of the time, this thing will pay for itself. Can it pay for itself in 4 years? Well, depending on how many heat pumps you put in and what your goals are and expectations are, yes, it can absolutely pay for itself in 4 years. I've seen it do it in less, right? But then, if you change your habits or anything like that, if you heat with oil, I mean, oil is just like you don't know, right? You're 50 cents today, you're 90 cents tomorrow, you're $1.50 next week, right? You just don't know where oil is. Sometimes it's saving you $1,000 a year. Sometimes you're breaking even. Sometimes it costs you an extra $20 a year to run because it gets below 70 cents a liter, which is absolutely mental. But it will go up someday soon. All right. Should ducts be cleaned before going on a ducted system? I'm kind of on the fence about that. I don't think that you're really going to get any benefit. You're certainly not going to get any benefit from efficiency out of cleaning the ductworks unless they're absolutely hanging. But I think I don't know. I would say I wouldn't in my house, but you might in yours, and it would definitely get some dust out. That's for sure. All right. Hybrid hot water heater. Does it have a pump to circulate the hot water? No, it's basically just treated as the same as a regular hot water heater, right? So this is this is a little bit of a funky one here, but this is the marathon tank. So your cold water comes in, your hot water comes out. It's the same with the heat pump hot water heater. Your cold water comes in, and I think this one actually has the hot water that comes out the bottom of the tank, because again, with the heat pump hot water tank, essentially what they're doing is the refrigerant is actually running around the tank in a coil, right? So you actually this also has electric hot water heater in it as well. So those are electric elements there. So if you ever ran out, or if the heat pump ever broke, or if you ever had really high demand, like you had 10 family members over and you all decided to take a shower at the same time, it does have electric backup in it. But essentially, when you have an electric heater, you have an element here and an element here. They get hot and they're trying to reach the middle, and this one's trying to come up and this one's trying to come down. Well, the heat pump hot water tank actually is a heat exchanger. So it has a coil that goes all the way and comes all the way down to the bottom. So you get a real even temperature. You don't get these kind of cold spots in a tank, which you might find in a traditional electric hot water tank. When you sell your house, does the warranty stay without? So when we're selling a Fujitsu, right, you didn't hear it from me. Yes, we will. The warranty is registered under the address. But if that person calls another Fujitsu dealer, they may not honor that warranty. However, we will. All right. So how quickly does a ducted heat pump heat the house compared to a normal furnace? So it all depends on the temperature. The colder the day, the bigger the distance, right? In the shoulder seasons and all the way down to December, the end of December, it doesn't take long at all for the heat pump to heat up a house. You can do it in 10, 20 minutes. If it's minus 15 or 20 ambient outside and you turn the heat off for 5 hours and all the heat went out, and then you turn the heat pump back on, good luck. It's not going to be for a day or two, all right? Unless you use that primary heat in order to kind of quickly get that temperature up there. And then the heat pump can then maintain that temperature once it's been achieved. How far from the ceiling does the unit have to be? Okay, yeah, that's a good question. All right, so most of the heat pumps are anywhere between 11 and 12 inches top to bottom. All right, they breathe from the top, right? I mean, I've seen them go as low as 2 inches, but really you want to see 3 or 4 inches off of the unit. Off of the ceiling. So basically, from the top of the ceiling down to the bottom of the unit, your minimum distance is going to be somewhere around 15 inches. So if you're trying to put it over a window, lots of times that can't happen. You have to have a high ceiling with a big 18-inch gap, because even if we're putting it over a window or a door, you also can't forget the frame that goes around that window and door. We can't go through that frame. We have to go above it. So if it sticks up 6 inches and you've got 20, I still can't go through it. So it all depends on the house. All right, any more? We're just waiting on some questions here.
Noisy fan, 2 years old. What could it be?
Noisy fan, 2 years old. What can it be? It can be a fan motor kind of on its way out. That can happen. It might not be the greatest heat pump. Again, it could be that, again, if you haven't had it clean, the dirt's going to get up in here, right? And eventually it's going to spread over to that fan wheel, and it's going to clog up the fan wheel. And then you're going to burn out your motor, or you're going to get kind of a grind or a tick. Any of these things can happen over time. So again, that goes back to that kind of proper maintenance. You don't buy a car and not get the oil changed. You buy a car and you get the oil changed, and that car is going to last you a long time. You don't get the oil change, well, you're going to get 20,000 kilometers out of it, but then that's going to be about it because your engine is going to blow. Okay, so this is something we haven't talked about yet. Financing options. So we do have financing options for these. Nova Scotia Power has their on-bill financing program. Pretty simple application. All they want is your name, your account number, your address, your job, or whatever. If you're retired, it works too. And then we send in your application. It takes about 3 to 5 business days to get back to us with approval. Once we have the approval, we book the job. You can book you can finance from 3 to 10 years. It is 7% interest. But like for the Fujitsu here, this 12,000 BTU, which is our #1 seller. Like I said, just about any house out there could definitely benefit in some way from a heat pump. Just about everybody. And if you don't like the look of it, maybe you go with the floor one down there. And if anybody joined late, there is a floor mount model down there. But these are running in somewhere around $50 a month on a 10-year finance. So not crazy. If you heat with electric, chances are it's going to save you more than $50 a month to put that one on that main floor. So if it saves you more than $50 a month, heat pump free. Free heat pump. All right. No, so 110 volts. No, a heat pump does not come off. Well, there are, but you don't want to buy them. This is 220. All right. So we need a 2-pole, two actual spaces. All right, in your breaker panel. So breaker panel, a little bit of a breakdown. So breaker panels, they have all these spaces, right? Oftentimes, like this one here, the Siemens one, and they have Square D and Eaton, all of those ones. They can generally, like, even if your panel looks like it's full like this, doesn't necessarily mean it's full. Sometimes we can put mini breakers in and double up on some of these breakers that you already have. But they are 2-pole. So a 12,000 BTU and 9,000 BTU in pretty much any brand is going to be a 2-pole 15 amp breaker. Now, I don't know if you know much about you. may not know about much electricity, but that's basically equivalent to running a little 1,000 watt baseboard, right? So they really don't use a whole lot of power. So heat pump covers. I am not personally a fan of heat pump covers. We do have them here. We do sell them. But this heat pump here, right, it's actually made to be outside, right? It's meant to be outside. It's powder coated. It's built like a car. So it's meant to be outside. It's meant to get rained on. It's meant to have wind pound against it. It's meant to have ice fall down on it from the roof. Of course, if it's, the size of a bowling ball, yeah, you're going to smash your machine up. But, every day in and out, environmental disruption, it's built for it. One thing that our guys don't like is when you put that cover on there and they want to come in and they want to service this thing, then they got to take the friggin' thing off, right? So Down the road, you might find that it actually costs you more to service it, because I believe that's something that we are actually looking at as far as a difficulty level, because it could take you an extra 35, 40 minutes on a job site to take that thing off, do all your work, then put it back on again, right? For new construction or mini, so like new construction, mini splits versus ducted, I mean, it really depends on you. Like this, if you have like a split entry bungalow, 2 of these to do the whole house, you're never going to get a cheaper way, like, unless you combine the ETS unit with it. That is the cheapest way, right? But again, when you have this in and it's a split entry or whatever, raised bungalow, regular bungalow, and you've got kind of like, let's say this is your kitchen, dining, living room area, all this area, right? And then you kind of have, and then you have that hallway that runs down this way to the bedrooms. And then you've got 3 or 4 bedrooms off to the side here, right? So what happens is the heat pumps here, it blows down the hallway, it really kicks butt, and it goes, oftentimes it goes all the way down to the bedroom and does it great. But the bedroom doors have to be open. And the only way to get that air conditioning is to have the bedroom doors open. So if you have a dog that you don't like, or a cat that you hate, or you don't want the kids to come in the morning and roll all over you, you might be thinking about a ducted heat pump, because that way you have supplies in every single room. You can shut the doors at night, and then the air flows back under the doorway to the returns wherever they are. So it all depends on what you're willing to spend, because doing a ducted one is going to be more expensive generally, especially in new construction, than putting in a couple of mini splits and then dotting around a few baseboards as your primary, right? So really, they're both the best option. It's just what's the best option for you, right? How long does an assessment take? I mean, again, as short or as long as you want. I'm willing to always answer as many questions as you have. But again, I've done this so many times now. I can be in and out of your house in 10, 15 minutes and tell you exactly what it is that you need, because I've heard pretty well all the questions before. So so it doesn't take long. Financing options for solar, that's a really good one. Solar, solar is awesome, man. Like, I really hope that, people really get into this a little bit, especially this time, because that rebate is so big. You're never going to see that kind of a program again where they're going to fund that much of your solar project. Because I've been doing this a long time now. What they do is they start out and they go, oh, wow, you get all these huge, and then they chop it 10%, and they chop it 10%, and they chop 10%. And then all of a sudden, it's going to be down to nothing. And it's just going to be worth doing it even at that stage, never mind when there's $6,000 off, right? But financing for solar panels, we try, and there is Solar City program. So the Solar City program puts it on your property tax bill. It is 4.79% interest of 10 years. But we try and get people into a more flexible and fluid program, and that's through Credit Union Atlantic. Now, they do this with the heat pumps as well, as they actually have a green financing program. And that green financing program, if your credit on approved credit, is 4.49. It's the lowest of any rate that I've ever seen in this industry. They actually do a really good job with it. They do want to try and win your business when you do, but you don't have to have an account with them. You don't have to do anything except for it's a little bit more of an in-depth application process. Whereas Nova Scotia Power is just a one-pager, off you go, take you 10 minutes to do it. Credit Union Atlantic is going to be a little bit more work. All right. And again, that's 4.49%. So how much the ETS units cost? So on that one there, that's down there in the corner, that's a 208. Generally, we want to do one slightly bigger than that. Usually we're doing a 408 at the minimum, or a 308. So it's a little bit wider. That you're generally looking, because we also put a timer on the hot water tank as well, so your hot water tank charges at night. So you save 50% on your hot water as well, effectively. That is usually around $2,300, $2,400 plus tax for the ETS installed. We pull a permit with Nova Scotia Power. We put a timer on the hot water tank. It comes out when the dust settles. It comes around to about that plus tax. I do hear that they're potentially going to be doing some rebates on ETS coming up, starting maybe even as soon as next month. But again, we'll keep you posted. We always send out emails, and we're always advertising all of this stuff just to keep you informed, so that you know exactly what's going on, where the best value is. If you have a fuse panel. So if you have a fuse panel, glass fuses, I'm assuming, and you want a heat pump, right? So your glass fuse panel is a little bit different than this, but you have all of your fuses down here, right? If every single glass fuse all the way down to the bottom is being used, you can still get a heat pump, but what we have to do is put something similar to this in, which is called a pony panel. So effectively what we do is we steal 2 circuits from that glass fuse panel. We run a wire to a secondary fuse box, and that would allow us the breaker space in order to fit another or multiple heat pumps, and then maybe even give you another circuit if you wanted to use that for something else in the house as well. So yeah, that is generally possible. A lot of times what we also do, because we do service upgrades, and if you want to change your glass fuses to a breaker panel, we do that as well. We do anything electrical. So anything electrical that you're looking to do, we are able to do it. Let's see what else. Should your heat pump be, again, should your heat pump be cleaned once a year? Yeah, once a year, at least every 2. Best practice once every year. Okay practice once every 2 years. Anything beyond 2 years, you're costing yourself money, and you're putting your machine a little bit in danger of not lasting as long, or being as efficient, or putting out as much heat, or cooling as well. So I mean, it's a huge effect that can have on the heat pump. If you have 1 compressor and 2 heads, can one no? So excuse me. That is another thing about the single zone versus multi-zone comparison is. So if you have 1 compressor, right, unless it's like the newest thing, like a VRF, which residentially we don't really do, unless you have like this creme de la creme, if you have 1 compressor and 2 or 3 or 4 heads coming off of it, or indoor units of whatever kind, whether it be floors and attics and everything like that, they all have to be on the same setting. So they all have to be on heat, or they all have to be on cool. They don't always have to be on the same temperature, right? But they all have to be in the same mode, right? So every heat pump has to be on heat, or every heat pump has to be on cool. Now you could have one at 15 or 16 or 17 or 18 and 19 degrees. You can have all 5 or 6, 7 different temperatures, but they all have to be doing the same function. So they all have to be heating, or they all have to be cooling. If you try and put one on heat and one on cool, whole system's going to go down. All right. Do you sell small ETS units, and what size does the ETS heat? So 4 sizes in the ETS units. Right, we will not sell you a little tiny ETS and get you on the time of day meter. All right, we will sell you the appropriate ETS to get you on the time of day meter. All right, so the way the sizes go is the 158 is like 1,000 watts, and that can do like a 10 by 10 bedroom. All right, number 2 is a 208. That'll do like maybe 150 square foot bedroom. Right, a 308 will do maybe up to about 300 square feet, which is a 2 kilowatt system. And then a 408, which is their biggest, will do anywhere from 300 to 400 square feet of space. Anything that you go beyond that, like if you have a basement and you have like a 400 square foot rec room, and you have a laundry room, and a storage room, and you don't care about heating those, it doesn't mean you have to put one in every room. But you do have to, that ETS that you're putting in that space, it has to be enough ETS to do that space, because these ETSs, they also have what's called an emitter in them. So essentially, this is a baseboard as well. So you have your bank of bricks inside of here, right? It's set all like pancakes. There's like 8 of them, I think, in this one. And they're all back. And then, so this thing inside gets hot as hell. There is an insulation there, so you can touch it. I mean, the kid's not going to put their face on it or something like that, or they'll only do it once. Inside there as well is an actual heater, just like a baseboard, right? So there's an emitter, so that if that ever ran out of heat and you still needed to heat your room, then that baseboard could kick in and do it up. All right, so we've had lots of questions. I've tried to answer as many questions as I could. I'm running out of steam. We are going to be running this thing again on Saturday. I'll probably be doing a lot of the same stuff again. And then, maybe some more questions will come up at that time. You're more than welcome to come. We are entering everybody who attended the session into a draw for a chance for a heat pump. We will send that information out afterwards. So thank you for coming. I'm hoping that we are going to be doing these more down the road. Please don't hesitate to contact us anytime for questions or a free assessment. Thank you very much for showing up, and hopefully you'll invest in a heat pump or some energy efficiency. No. All right, that's great. Thank you very much, everybody. Have a good night. Okay, shut it.